So here's the final circuit. I've got a photoresistor here, and I've got a 1K resistor here performing a voltage divider, and then this top orange wire is going over to our digital input, and just for display purposes I've put 4 LEDs on them. Now these LEDs already have resistors in them, that's why I don't have a separate resistor on those. So when I cover this up entirely, all of the lights go out, and then when I grab my makeshift light, you can see when I put that over, it gets maximum, and you can see those LEDs going up all the way up to all 4 of them. All right, so let's go ahead and take a look at the code, and I'll explain a little bit as to how I set these up for those LEDs. So here's the code. So in the setup, what I'm doing is I'm defining my serial output, and then I'm defining my analog input, and this is going to be where our photoresistor is, as an input. And then I'm defining these spots for the LEDs in digitals 2, 3, 4, and 5, and they're all outputs. Now in my loop, I'm just saying, give me the value on an analog read of that digital port. So that's going to tell me how much resistance is on the photoresistor, and that's going to be stored in value. Now the next line might look a little bit confusing, but what this is doing is it's saying, okay, take that value, and I want to map it to a more consistent number. Now by default it's between 0 and 1024, but I did some checking, and I decided that when my room is normally lit, the low value is about 200, and then when I shine my LED on it, it's around 400 to 500. You can see it changing right here on the far right in my serial console. So it gets up to 600 or so, but it doesn't really matter when there's no light. It's about 200. So what I'm going to say is I'm going to say map it between 200 and 400. I want to just get a consistent value of 0 to 10. Now the reason I'm doing that is I just want to have a short bar, and this is going to be this little bar that you see pop up over here on the right. So it just gives me a little bit of a little line to indicate how much light is coming in. So you can see when I put the light over it, it goes between 0 and 10. So 0 and 10. Now if your room is lighter or darker, you may need to adjust these values. You'll see them in here twice because I'm also going to use the same function in order to determine exactly how many lights of the LEDs to light. Now the next section, what I'm going to say is we're going to print that value to the screen. And that's the number that you see here. Over here on the right, you can see those numbers. And then I'm also just going to put a little dash for each one of those 0 to 10. Then I'm going to print a blank line, and that just makes it so that we've got a line feed in between each, otherwise they'll all be strung together. Now the next section, what I'm going to do is I'm going to map again. I'm going to use those same values, 200 to 400, but I want 4 LEDs. So I'm going to go from 0 to 4. Now the way this ends up working, that might be a little bit confusing, but it's non-inclusive. So it will give me a value back between essentially 0, and then it'll be a little bit of a higher than that. So 0 to 4, essentially. Now the first thing I'm going to do is I'm going to turn all my LED lights off. So I'm going to write all of those low. 5, 4, 3, and 2. They're all going to be off. Now I'm just going to do a couple if statements. And I'm going to say if LEDs is greater than 3, that's the value from my map, then I want to light the last LED. So LED 5. So I'm going to digital write 5 high. Now if LEDs is greater than 3, then I'm going to write 2. And then if it's greater than 1, I'm going to write 3. And then if it's greater than 0, I'm going to write 2. Now again, because that's inclusive, it could be 0 if there's no light. In fact, there's no light right now and there's no LEDs lit. But then when I put this over it and I light up my photoresistor, the value is greater than 3, and so I get the 4 back, and now it's going to light all 4 of them. And then the last statement is just to do a delay of 50, and that's 50 milliseconds, and that's just going to make sure that it doesn't repeat too quickly as part of it. So anyway, that's the code. I'll include the code. Now let's look at the circuit diagram so you know how to wire it up. All right, so here's our breadboard, and here's our Arduino. I just drew a couple of the pins. We're going to care about A0, and we're going to care about 5 volts and ground. Over here, I put the photoresistor in between 2 of the breadboard pins, and then I have the 1K resistor. Now this is going to be that one that looks kind of like this. This is actually not a 1K, but it's the brown one. It's not the blue one. So you should have a couple brown ones in your kit. So put that 1K in between any one of these pins and ground, And then we're going to also put the photoresistor across two of these. So it'll go one on the left and then one on the right, and make sure it's in the same one as the resistor. Now this is going to be the ground. And then we're going to tie ground to ground. So we just want to make sure we have a wire in here to ground. And then we want to take the 5 volts and we want to run a wire from the 5 volts over to this other leg here on our photoresistor. So it'll go 5 volts to one side of the photoresistor and then through the photoresistor through ground. Now what we're going to do in order to do that voltage divider is we're going to take a pin from the A0 and we're going to put it right here, right in between these two. So it's going to be between the photoresistor and the ground. Anywhere within that strip here on the breadboard will work. But this now takes a tap out of that as a voltage resistor, and now we'll be able to read it. So that's how that'll get wired up. And then if you want to put the LEDs on, over here I used 2, 3, 4, and 5. You can just simply run a wire over to the other side of the breadboard and then put in each of your LEDs and then run them with a resistor, one of the blue resistors, to ground. And then make sure you run a wire from this ground to this ground and you'll be all set. So that's all there is to it. Pretty straightforward.